Hello everyone. So today we will be seeing how to reverse a linked list. This would be the logic building exercise, taking you from the best approach, which is the bare minimum which you can think to reverse a linked list, towards the best approach, from the stupidest one to the best. Yeah, that's true. This is how the logic building works, and most probably this will help you in other sorts. Even if you know how you need to reverse a linked list, you might be take few of the keynotes from here. So else you can have a better understanding of logic building. So without any further ado, let's get started. So let's first discuss what the linked list is. So linked list is for now will be just go ahead with a very briefing of the linked list. So as of now, you can just remember that linked list is just a chain of elements, chain of nodes, which it handles data within each node. So more brief of the upon the linked list could be found below. I'll link down the video description within the comment itself. You can go ahead and check that out. For now, you can see that not everything needs to be stored within an array, right? And there might be various reasons where you need to have this list. Let's suppose one reason is array has a very limited capacity, whereas the linked list has not such exceptions. Whereas you can have any abstract data type within the linked list. So what linked list is? This is one of the node within a linked list which has one value assigned to it, or you can say a data point which is assigned to it, and it has a next pointer. What this next pointer does is it points to something of its own next node of the linked list. So okay, this one. So here we can say one is pointing to 2, and meanwhile this next is also pointing to another node. Here we have a list. Also do keep in mind that this is not in a sequential manner. So these are the data entries which are scattered within your memory itself. Sometimes this may not be within your memory, so you can take it from the virtual memory, pull it into the physical memory, sorry, logical memory, and then start working upon it, and so on. So having said that, this is the linked list, and where this node is also having a next pointer, which will be having a next value as null. So null it defines as it is an end of the linked list. There is no further element with beyond this. So this linked list has three nodes of data 1, 2, and 3 each. So this is basics of the linked list. To find more of the variations within the linked list, what is doubly linked list, what is a threaded linked list, what is skip list. You can go ahead and find that video below. I'll link this. So later, what is reversing a linked list? So the reversing operation upon a linked list means you have given a linked list and you need to reverse it. It means such like this, like 1, 2, 3, 4 would be reversed to 4, 3, 2, 1. Note that null is still defined as the end of linked list. That's how it is. That's how we demonstrated the ending of the linked list. Next, what all approaches we have here to do the reversing of the linked list? So it's n square n and n with space of n and 1. So do not bother much over here. We'll be going ahead within each of the approaches in the coming time. So for now, these are the three approaches. Let's dive deep into it. So this is a brute force solution. This is the O of n square, which has n square time complexity. It's a basic approach. It's a most minimalistic approach when you see about the reversing. So what reversing means? The first thing comes into your mind is you take the first element and you put it into last, or you take the last element, put it in the first, last second, second, last third, third, and that's how reversing the operation means. Yeah. So it's just like 1, 2, 3, 4. You take the last element, you put it over here, and it's the first element. You take the last second, third, this, and so on continues. And the end product you will see is you got a new list. Quite simple. Yeah. Uh, so while putting it down on a broad level, we are doing nothing but we are taking the last node, and if we have the existing list, we are appending it to the existing list. As in case of three, we took three and appended into the list. If the list does not exist, then we create a list with a 4 or with a node which we provided as a starting of the list. And we keep doing this until we have done iterating over the entire array. Oh, sorry, entire linked list. But this is the stupidest approach. This is the most naive thing which you can say within your interview itself. You can just describe it and you can just go ahead with the second approach. You can describe it in such a way because this is something like it takes O of n square. You need to iterate this for each insertion. You need to iterate the linked list twice. So that's not a feasible way to go ahead. So that's why you can just orally explain it and you can go forward. But still, we are going deep into it and we are starting to code it. So let's enter into the code. So welcome to the coding of this problem of reversing a linked list. Here I have used a lead code platform so that we would have a better test performing. Let's go ahead. So it says we need to have a we need to complete this reverse list function. So for this, we'll just go ahead with the previous method. We delete the last and insert into here. So we need to have one method known as list node delete last node. So once we have this func method which will accept the head of the linked list, and we'll delete this last node and we'll return the last node, keeping the list consistent as 4 should be pointing to null. So let's check whether head itself is equal to null. Then this is not a valid operation, and ideally we should throw here an exception. Uh, it would be legal argument exception to be precise, but for a while I'm using just exception. So throw an exception known as list is null. Okay, that seems good. Just return null so that we are consistent with the compiler, as this won't go beyond the scope. Post which we'll just iterate while head dot next is equal to null is not equal to null. Oops. We'll just iterate head is equal to head dot next. The moment we see head dot next is equal to null, we know that we need to return the head. As we see the head dot next is null, it means next of 5 is null. We can retain the head. But what about 4? 4 should be assigned to null, isn't it? So we need to have a new variable known as previous. Previous is equal to null initially, so that we might not avoid any confusion, or let's take it to head. So previous is equal to head, and ultimately so what it does is it keeps a track of previous node. So in this case, when the previous is assigned to head, it is 1 and head is then moved to 2. So every time previous is the previous of the current node. So node is 2, previous is 1. Node is 3, previous is 2. In such a case, uh, now we will just keep it consistent. Keep list consistent previous dot next is equal to null. So we are saying previous means in this case 4. 4 next of 4 should be null, and we are deleting it, and we are returning the last node. Simple, is it? Isn't it? And we'll just go ahead and we'll just take each node while the head is not equal to null, or head dot next is not equal to null. And for the simplicity case, we'll just also take head is not equal to null, so that we are avoiding the initial case where you have included the head as null, right? Yeah. We'll also take a node reversed is equal to null. So, and we are saying if reversed is equal to null, that means reversed list is not yet created, right? Else we know reverse list is created, and in such case just append to the reversed list. Okay, and in such case create a form a list with the removed node. So we need to form the list with the removed node, but we need to get the removed node. So in such case we'll just say list node removed node is equal to delete last node, the function which we have written just now, this one, head. Now we have reverse is equal to null, and we do not have this as, and we just need to append it. So in the other case, but in this case where we do not have, so we say reversed is equal to removed node, and in such case we are saying append, append to what? Append to this reverse list, reverse, what should we append? Removed node. So this method is not yet created, we need to create it now. So we'll just copy and we'll just create it now. Is it returning anything? Uh, Not basically, it's not returning anything, although we can make it optimized by returning the last pointer, and last pointer will just dot next dot next dot next. We need to append it. And that would be so simple, but we are keeping it a stupid simple. So we'll just go ahead and make it work. Optimization part we'll be seeing in the next point as you'll be sticking to this video. So void, as we are not returning anything, list node list comma, okay, I'll just say list node uh, inserting node. I'm very bad at naming, please pardon me. So if list node is equal to null, it should also be not a valid thing, and we are not accepting such case, and in an ideal scenario we should throw an exception over here. So let's just do one thing, we can throw the exception over here. Yeah, we can throw an exception over here, so saying that the list is already null, so we cannot append it. Although the sensible way is to go ahead and use this as a list, but we are not sending anything. I mean, we are not returning anything, so this approach is not working. And yeah, we'll go ahead with the best case, the worst, the illegal case we have handled, and the legal case we are going ahead with. So while we are saying list node dot next is equal to is not equal to null, that means we are having a new element right next, new element right next, new element right next. We are iterating list node dot is equal to list node dot next. And the moment we see, like in such case, the next of 5, the next of 2 is null, we go ahead and insert. So list node dot next inserting node, inserting node. Yeah. The one thing here we can do is like we can make sure that inserting node is an independent. So what do you mean by independent? Independent means, let's suppose I have an inserting node as 4. It might be a chance is 4 can have the next pointer as 5 and everything. So you want to just append only the last element, which is 4. So we can do one thing over here saying that inserting node dot next is equal to null. So this is something we are losing the data post which is not required, but if you're very certain that you this is your use case and you need to do this, you can do it. For now, I'm commenting it out as this is not a use case. Why this is not a use case? Because we have handled such case by assigning it null. So we already know whatsoever node we have deleted, it's the last node, and we are using and we are having no new elements post which. Okay, so this is how we have reversed it, and we are just returning. Okay, return reversed. Have we missed anything? Okay, the spelling. Pardon about that. I think it's the same, right? Yeah, it's the same thing. So have you missed anything? Let's see. No, it is not the case. I was thinking something is missing. So let's run again. Mm, reversed. It's reversed and not reverse. Any more errors? Compiler. It's list node, not load. Line number 49. Yeah, it's list node, not node. Okay, let's run it now. This is what I'm saying. So we need to declare it that we are throwing an exception, and that exception needs to be handled over there, which will mismatch with the signature. That's the reason I comment out such kind of things and return. Okay, it says not working. So we are missing the last element. So any ideas why we are missing the last element? So we are missing the last element because we are seeing head.next is not equal to null, and we are only remained with the head. And if head is not equal to null, we just go ahead with append reversed with head, and head dot next is equal to null. Although the head dot next is equal to null is optional, but just for sake, as the append method is full append and not the uh, individual node append. So what is mean of full append? Let me also remind you that if you are going to append 3 to this node, let's suppose 1, so it will take 3, 4, 5 and will append directly post 1. So the list will become 5, 4, 3, 2, 1, 3, 4. You're getting this point? So although this case is not likely to occur in such cases, but yeah, just added for the sake of clarity. Whenever you're coding with an interview, just don't avoid such kind of things. So removing this. Let's use this test case and no thanks, run it as it is. Not sure why we're getting such kind of things. Okay, okay, got it. So if head dot next is equal to null, head equal to null, or head dot x is equal to run, return head. Let's run this. And yeah, we have submitted it and it's working fine. Although this is a stupid approach, this is a beneficial one. So as how we as a human understand things. So we as a human go ahead with this approach. This is somewhat tiresome approach. Why? Because we are uh, keeping iterating through each of the nodes multiple times. While we are deleting the node, when we are appending it, it brings to a complexity of n square. To avoid this, we have mentioned it, but just in sake of interview, you can just explain this logic and you need not to code this very well. Although if an interviewer says that you need to code this out, just go ahead explaining each and everything. You're handling this null cases, you're handling this exceptions. This would impress the interviewer. It would be better if you just directly throw ahead the exception and you not enter the null. I've commented it out because I need to change the signature. I hope you understand about this. So that was about it. Just stick to the point that this is the stupidest approach, and no one would likely to say you to code about this. So you can just ignore. And whenever the code gets the lengthy, it gets more complicated, and the points need to be, the connecting points need to be are harder and harder to be get connected. So you need to connect this reverse linked list with the two more methods, append and where's the next method? Oh yeah, delete last. Yeah. So that's all from my side. Uh, Head on to the next one. See you. As we have seen how we have coded this, and coming back to the second approach, which you can have is it's the O of n time complexity and O of n space complexity. This is the one of the easiest way, not so complex. It's a pretty simple way. And what it is let's use this list which you have provided, and we have an extra space O of n, and within O of n we are taking one node and inserting into the list into the container itself. So, and we are taking second, we insert it again, third, and so goes with the fourth. And when do we wanted to take this nodes out, we take this, we pop this out from the container itself, the nodes. So we pop out 4 and we take 4 as an output list, 3, and so goes on for 2 and 1. So this is something sort of a stack architecture. So as you can see, this 2 and the 1 goes out here. So we can do this until the stack is empty for us, and once it is done, we are we are having a reverse linked list in the return. So what this is in short is, from the list which we have provided, put each and every node. What we did is put each and every node into the stack. And once that is done, our stack is filled and we have iterated the input list entirely. This list is has been iterated entirely. Then we can go ahead with the second thing, that we can take out the nodes one by one from the stack. And once we have took the node out, we pop the node out and append the node to the output list if the list is created. Else if the list is not created, uh, the popped out node would act as a head of the new linked list. The new linked list means the reverse linked list. Do mention this 5 is nothing but null, which we have an indication as end of the linked list. And once it is done, then once it is reached, then we can conclude that the list is iterated. And same goes over here. So let's code this as well. So welcome back again to the second approach, and probably this is the most simplest approach and also better than the previous one approach, as this requires only O of n time and O of n space complexities. So as a result, as we have seen, the best way to do it is via stack, as we are going with an operations of push to insert and pop to take it out from the container. So without any further ado, let's get started with the simplest approach. So we'll take up a stack. So stack list node. We'll take just a list node and name the variable as stack itself. And stack is a class provided by Java, so we don't need to worry about it. It's directly inherited from the vector. So we have a stack, and for each node, so we'll say while head is not equal to null. So we are saying head is equal to head arrow dot next, as we are going further and further, and stack we are saving within the stack, so stack dot push the head. So as of now we see that our stack is full of nodes, and now we just need to pop it out one by one. So one should go ahead and argue that I can do this by taking out an element and joining next. Although the better way it's going to be that you can create a new node whenever you see the pop out the elements from the stack, and that's also the simplest and most probably the cleanest way to do this. So we are preserving this list as well, and we are not altering that list, and we are creating a new list. This is a better way to showcase your skills within an interview, saying that we are not altering the initial list and we are just reversing the list and returning it. So, okay, so while we are saying that stack dot is empty, so we don't want to pop out from the empty stack, we'll get stack underflow, and we'll see what we can do over here. So we can take a result as result which is equal to null, and we are taking list node iterator, which is as which will iterate over the result list. Result is the head of the newly formed list, which is the reverse list. So we'll see if this result is null, then we are saying that result is equal to itr equal to uh, stack dot pop, and this is probably the first step. Initially you can go ahead and just pop it out the stack element, but we are unsure that stack itself can be empty, so we didn't do it over here. We are checking it within the loop itself. So one can argue that you can take this and you can put it over here, but no, that's not fine. If you need to do this, you need to encode this within block this within a try and catch. Of course, if this is not null, we are just taking it as itr. Okay, if it is not null, we are just taking the iterator. Where is the iterator? Iterator dot is equal to, sorry, iterator dot next is equal to uh, stack dot pop, the new element which we are finding over here, and itr is equal to itr dot next. Hmm. So so this is how we are iterating it. So if it is having the result, if it is this, so as of now we are done. We have reversed it, although you can take it like you can reverse it within the fashion like you can create a new node, but that's okay, that's up to you. And ultimately itr dot next equals to null, as this one might be pointing to something else because it's the first node it's pointing to two, and it will create a loop over here. So we don't want to do that. So return. This is not required if you go ahead and create a new node. As we have mentioned, we'll create a new node. Let's go ahead with a new node. We'll do both for your convenience. You can choose any one of it. If you have a list node, you don't need to worry about it. You can just go ahead and make changes over here. Also, we do not have any constructor of list node containing just list node itself. So we are taking the value, right? So we are taking the value here as well. Well, oh, sorry. I forgot to return the result. So what does it say? It say that okay, it needs a new stack. New keyword is missing. Anything else it wants? No, nothing. Spelling mistake, typo. Okay, so it's accepted. Let's submit it out. Yeah, it's accepted. We have did it successfully by using a new linked list. So we have created a new list over here. One can argue that you don't need to do this, and why also I'll get into this. Why not new list, and if why so? We'll debate upon this question later, but first of all, we'll just go ahead and check out this solution as well. Okay, ITR itself is null, right? What's null? See, that's what I was saying, referring to it's uh, what do you say? It's a cycle within the linked list. So one can say that ITR dot next equals to null, and you can go ahead and assign this. So this individual node we see is null, has next as a null. Both can be treated as an independent nodes itself. So running this up, it is accepted. Note that the previous solution took 2 milliseconds and this solution took 1 millisecond. Why so? So as we are seeing that previous solution within the previous one, we have used new operator. Uh, Let me inform you that whenever you create a new objects within Java or in any of the programming languages, it is allocated mostly within the heap memory. And when so you do so, there is some time duration required to do that. Okay, as per your language, it might be a deep copy, shallow copy, whatsoever. Shallow copy is comparatively less time, but still time is required. So this is why we are refraining from doing this. And although this approach is a cleaner approach, you are not altering the input which you have got, and which is a good thing, but at a cost of the memory which you lost and speed as well. Whereas this one, it's more like it's more logic oriented, where you say that we have next is equal to null. Either you need to comment it out saying that I want just independent node like this, or you can just go ahead and remove this and make it cleaner, saying that's clean stack. Instead of stack, you can go ahead and say I want clean stack, and there's no such class as a clean stack, so remove this. Okay, what does I mean by clean stack, by the way? So by clean stack I mean that I want only the stack with node list, only the list node, sorry, knows list node as clean node, which is head. And let me remind you that clean node dot next equal to null. Before before doing that, we'll lost the null, sorry, next pointer, so we'll just iterate the head. And when I'm saying that node is clean now, clean now, by clean I mean there is no next pointing to it, it's an independent node. So just take ahead and clean node, push it over here, and you don't need to have such line, and that's clean. So this approach is clean, and this approach as well. Stack dot pop. Oh, there's no stack, there's a clean stack. Clean stack, huh? Let's go ahead, compile it. Okay, sample test case is passed, and this is, yeah, not sure why 2 millisecond is shown over here, because logically this is the more cleaner approach and less time consuming, maybe due to the computation at the end. Yeah. So also, if you want more specific upon the speed, this is not the solution you need to stop upon. Also, you can have a solution where this we are not taking any of the space. That is why that solution you might think to look upon. So the last approach is of the time complexity of OFN and space complexity of OFN. So guys, I want you to here pay full of your attention, because this is the probably most confusing thing, and most of folks try to mug this up, but that's not what programming means, right? Programming do means like you understand things, and you know the method, you know the tech, go ahead, implement this. So what this is like, understand how the reversing works. Now let's do it. So if you want to reverse this current node, let's say we have a sub list. Imagine we have this previous list over here, previous list over here. We have to reverse this current node. Okay, what does it means is like the current node which is now pointing towards the next node 3. 2 is now pointing towards 3. 2 should be now pointing towards 1. Isn't it right? Yeah, that it is. So this is what we say that current node is now reversed. It should be it it was pointing towards 3. It should be pointing to 1, and now it has been over. So obviously this is what essence of the current logic is. So we have made it. Let's do the same with a node 3 as well. So in order to reverse it as well. So, but for doing this, we need to increment the 3 pointers, current, next, and previous. So these are just pointers which we have to identify the locations of the next, current, and previous one. So in order to keep the tracks, as we want to uh, go ahead to the next pointer, we need to reverse the current one, and we need to point the current to the previous one. So these 3 pointers are required for it. So incrementing the 3 pointers means uh, taking this. So the same one, we need to reverse the node 3 as well here. So 3, which was initially pointing to 4, we need to 3 to point towards the previous. So within the box, you can see that node 3 to node 2, which was earlier pointing to node 4, current dot previous is equal to current dot next is equal to previous. So the next of 3 should be the previous one, which is this. And now we can say 3 is also reversed. What else? We need to increment the pointers. Take previous to next, current, and the next would be also incremented in the next coming iterations. So it would be to null within the next iteration, not this. So let's go further. Same would go with 4 as well. Now 4 is pointing to 3. Forget about this, because 4 cannot be pointing towards 2 points, because there is only one next 4 node. So that is how we are. looking at 4 to be pointing towards 3 and not this. Forget about these things. Next, my friend, 1 is not pointing to anything, it is null. And as you can see that current and next is null. Current is null, so obviously, what makes sense to return in this case? What should be the head of the newly reversed linked list? From the diagram itself, it's clear that it is previous. So just don't waste your time and go ahead and return this previous. So yeah, this is how we have written this previous and we have created the reversed linked list. Let's code this as well and see how our logic works within the code. Hi, welcome everyone back again within the coding session. So I would like to present over here how we can reverse a linked list, a single linked list by using O of 1 space and O of n time. Uh, hmm. So let's go further. As you have seen, we are just reversing the links. 2 is pointing to 3, now 2 will point to the 1. So for that we need to have two things. We need to have a tracker for the current node. Current node. Initially we'll take the current node as head as we'll need to reverse it from the start itself. But let's imagine a point where you're taking the current node. What should be the previous of the current node? Hmm? It should be null, right? Why null? Because we are taking this link, pointing it to the previous node, but the previous to it is should be null. That means the next of 1 post this operation should be null, which is true in the result case as well. So node previous node is equal to null. Okay, makes sense. And we will also have a node for the next iterator. So what is next? Next is something we are taking account for the next node. So why we are taking into account what is next node? Because we have dot next? No, that's not a fact because our next is being rotated. 2's next is being rotated to 1. So where we should be tracking with 3. This you have seen earlier as well. So let's do waste our time and let's jump into the logic how we'll be implementing this. So I'm saying I'm having current node, while I'm having the current node, it means the current node is not equal to null. I have something within the form of a current node. First of all, what I'm doing now, I'm saving the next step, of course. As while doing the further operation, I'll be lost keeping track of next node. So we'll be saving this next. Save the next location. Why will we losing the next location? Sorry, it's current dot next. So we'll be losing the next location as because we are pointing current node dot next to, let's suppose 1 is a current node to the previous node. 2 is a current node to previous of a 2, which is 1. So we are saying previous node. Did it? Did it. So what should be the previous node now? Okay, previous node. Okay, I have written, that's why I'm saying. I've written a full name so the color encoding is not showing up. Dot next. Sorry, previous node is equal to the current node. Why so? Because once you have a previous node as 1, your next previous would be 2. The next previous would be 3. That's how previous node keeps on incrementing. You can pause ahead and pause the video and go back to the slides where we have shown this. You can get a clear picture where the pointers move and how the pointers move. So this is how I have seen that I have rotated the pointers. Okay, let it be about the spelling. So, and advanced the previous node likely advanced the current node. Wha- This is a no-brainer because current node is being altered. Now there is no need of a current node to be do many more operation, and we need to skip to the next node. So current node is equal to next node. Okay, next is just next. Okay, the next node came from this point, which we have saved earlier, and that's how we are saying this. And when we are saying the current node is null, that means the next there is no any there is nothing to be reversed when we are getting out of this loop. And when we are getting out of this loop, what is the thing we need to return? Yeah, you're right, that's previous. Why previous? You can just go ahead and go back to the video and you can check it out why it is previous. So let's run this and check it. How is it working? It's not node, it's list node. Okay, let's okay change the class names, and that was it, right? Yeah, sample test cases are running fast. And yep, we have made it. It beats 100%. It means it's the fastest solution. Although do not rely upon this kind of timings because it is all usually uses the CPU timings, whereas rely upon the uh, notations, big O notations of one, and this is of n as per the EU algorithmic logic. So this we have done in of one space complexity of n timing. So ending notes is like so much amount of work goes into creating this kind of videos. Just wanted to know from you guys, do you like this or not? Show this kind of indication uh, by interactions within the video itself. I do not know whether this is a good approach or not, but most of or this is the case with you or not, but most of the folks which I see is like they are mugging up the such logic, and this is not what it is. This is not what programming means is, and just wanted to know that you should be clear within your logic, and that's how I've created this one. So do let me know if I can provide at least a bit of help to you, if my 2 cents work for you or not. And obviously, your love is more important than time which I have spent. So please show down your love, and that's all from my end.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust.